Hi, everyone. Thank you for joining this session with me today. My name is Vjosa, and I'm a platform engineer at Moss, which is a leading fintech startup here in Berlin. Today, we're going to cover how we can secure deployments on GitHub using OIDC. I will be mainly focused on Google Cloud Platform and Vault, and most of the examples that I'll be sharing today are using Terraform. So, what are we going to cover? Today is what is OIDC, why OIDC matters for CI/CD systems, how it works on GitHub, GCP, and Vault. And for each, I'll be sharing code examples and how we can use it on our GitHub Action workflows. Due to the time constraints, actually, I'm not able to really focus on details on each section. So we would assume that you have a Vault instance running on your infrastructure, and yeah, you're running on GCP, and you're using GitHub Actions, and you know basics on these technologies. I will be sharing an article very soon that would cover more details on those topics and specifically this talk. So let's start. What is OIDC or OpenID Connect? So OIDC is a authentication protocol that sits on top of OAuth 2.0. It's designed to enable secure and standardized user identity verification on the internet. It allows clients to request and receive information about authentication sessions and users using ID tokens, which is one of the key innovation in OpenID Connect or OIDC. So OpenID Connect is actually a very API-friendly specification, and it is commonly used for federated identity providers or IDPs like Google, AWS, GitHub, GitLab, Vault, etc. Um, Now, why OIDC for CI/CD? So OIDC enables CI/CD systems to utilize short-lived, dynamically generated tokens instead of static credentials, reducing the risk of credential leaks or misuse. Also, with OIDC, we don't need to store or rotate secrets manually in our CI/CD pipelines. So the identity provider, such as AWS, Azure, or GCP, issues tokens on demand. Also, it integrates really well with cloud identity and access management systems, and it enables precise control over which resources the CI/CD pipeline can actually access. And it also scales really well for large teams or organizations, as it leverages the role-based access. It makes it so easy to manage access across multiple environments in this case. And also, because we are eliminating static credentials, YDC enables organizations to meet compliance requirements for secure access management, for example, SOC 2 and ISO. Now, just a little bit on how GitHub OIDC authentication flow works. So first, we need to define this trust between GitHub OIDC and a cloud provider. So during our GitHub workflow job requests, an IDC token from GitHub's IDC provider. Then the generated token contains claims about the repository workflow, job name, and more. So we can see actually what this token contains in this example, which we have a lot of information. So once the workflow presents this token to the cloud provider that supports OIDC, the cloud provider then validates this token, and it checks the conditions based on these claims that we've already know. Then it issues these temporary credentials. So then workflow uses these temporary credentials to access protected resources. Now this is just generally how it works. And now we're going to go and see on GitHub like how we can configure this trust on, let's say, GCP in our case. So on GCP, we use something called Workload Identity Federation. And there's this three concepts that I'll be explaining today is the identity pool, identity provider, and the service account impersonation. So a pool is just a bridge between GCP and this external IDP, in our case, GitHub. Then the provider is just defines the trusted external IDP. We define the rules and how we're going to actually trust this authentication. Then we use service account impersonation to let an external identity impersonate a GCP service account. And we're going to talk about this in more details in just a bit. So how do we create a pool? Simple as that. We use the IAM workflow identity pool resource. We only need the name and the description. Then once that's applied on our Google Cloud Platform, then we create a identity pool provider. So this provider, as explained, we will here define how are we gonna define this trust between GitHub and GCP. So here we need the pool ID, the pool provider ID, and some attribute mapping. To know more on details for these, I'll share the link in the end. These are all optional. This one is required. Then we're only going to use certain one of these based on this attribute condition here. So once we define these attributes, then we can set certain condition on those. So for example, in my case, I'm saying I only allow authentication for main branch. Or we can say, yeah, everything from all GitHub organization repos owned by this organization. Or we can just combine these based on our needs as we see fit. Then we need the OIDC issuer URI, which this is the URL for GitHub. Until now, we just defined the pool and the provider, but we did not really authenticate yet. So how do we authenticate a deployment pipeline? In GCP, there are two ways. One is direct resource access, and the other one is service account impersonation. So the first one just grants permission directly to the federated identity GitHub workflow, while on the service account impersonation, we create a service account that acts as the identity. So we need to grant access permissions to the service account rather than the workflow itself. So some of the Google Cloud products have API limitations, and service account impersonation is recommended. And in this example, I'll be showing service account impersonation. So how do we do that? Well, we first need the service account that I just called it deployer. Then once we have the service account, we need to define the IAM policy. So we need the role workload identity user, and we need the members. So we can use the principal for single identity matching a certain subject, or we can use principal set for all identities that in a group or attribute that matches a group or an attribute, or even a pool, I think. So for this case, I'm using principal set, and here I'm saying that the attribute should be main branch. Then we need to assign this policy to the service account that we already created. And that's it. So nothing else is needed for this to work. Of course, if we use this deployer for deployment, we might need to grant access to certain other resources, such as probably artifact registry, or even like even some buckets or something like that. But do as you see fit. Now, on how do we use it on GitHub Actions? Once we have a pool, we have the workload identity, we have the service account, we granted the permissions, all is there. So we can define, as we said, this will only run on main branch. So we define the main branch, and we only deploy from main branch. So we need permissions, especially this ID token. It's needed because we need to fetch the GitHub ID token. And then we can define the step of where we actually authenticate to Google. And there is this Google GitHub Actions authentication action that we can use. We need to define the workload identity provider. We need the project number, and we need the pool ID, which in our case was GitHub, provider ID, nothing else. Then we just define the service account that we just already created. And we set here the email, and you can set access token lifetime. In my case, I just set 5 minutes. So everything after this step, if this went through successfully, then you're authenticated to Google and you can deploy or do whatever you need to do. Now, Vault. Here, generally, there are some different concepts, but for the same reason. So Vault uses this role binding and auth backend. Generally, auth backend is just an authentication method that enables our IDC authentication with Vault. Then a role binding defines the rules of how actually Vault handles this token for specific roles. We need some claims verification for repository or repository owner or branch or specific vaults to a specific vault policies. And yes, this policy mapping, we need some certain policy mapping between the authenticated identity to permissions that determine what actual resources the workflow can access, or what secret we're actually trying to access in Vault. Now, how do we do this in Vault side? So first, we need to enable this JWT auth. Once we have that enabled, we can create an auth backend, like here. We use this resource, Vault JWT auth backend. We define the path and the OIDC discovery URL and the bound issuer. These are both the same for GitHub, as we saw also for on the GCP side, and the path in my case is just GitHub OIDC. Once we have the auth backend, we can create the auth backend role. So here we just define the name, the bound claims, bound subject. In my case, I wanted to have a bound subject for one specific repo in the main branch. Here you can also define whatever you see fit, or how the authentication would like to be. Then we need this token policy. So we need to bind the policy, the Vault policy, to this backend role. In my case, I just said, in this path, secret data production CI, you can read the secrets. And then, we just create this policy. And we just set it here. Then we have the bound audiences for the specific organization. Role type, JWT, we need the backend that we just already created, and actor and the token lifetime. In my case, 15 minutes. It depends on the use case. Can be less, can be more. Once we just enable this in Vault, we apply these changes. We can use this on GitHub Actions. So similarly on GCP, we define the job. We define the job in certain steps. We also need the ID token right. We didn't add it here. And then for us to retrieve the secrets from Vault, we can use this official HashiCorp Vault action. And we just need the secret path, which in our case, we define a secret data production CI, the role name, and in my case, I'm retrieving all the secrets. But as you need, you can get certain secrets. You can change the name of the secret based on how you need it. This is just for us to show the example. We need the Vault URL, the Vault instance, your Vault instance URL, the method JWT, the path that we already created for the backend, and some certain other variables that we can set. I'm going to share more, the link that you can read more about this action. So you can use this authentication method for Vault for other reasons. This is just one of the examples. Like, for example, if you're running a Vault instance that you generate credentials for your databases, you can use this to generate, let's say, migration user credentials during deployment. So you kind of separate migrations and deployments. And yeah, you could definitely do something like this with this authentication. And yeah, the key takeaways is yeah, security, no static credentials, access control, integration, compliance, and so on. And yeah, thank you so much. Here I shared all of the links that I find it useful. Feel free to check them out if you want to dig deeper into this topic. And yeah, thank you so much.